This problem is looking at two similar triangles, and I'm not going over the rules for similar triangles. I am just talking about proportions when you have similar triangles. So in this situation, we have different units. I did a video where I was just showing how to do the proportion by itself. Now this one has proportion with different units on each of these triangles. Alright, so as we talked about before, with similar triangles, the same lines, or the lines that correspond, are proportional. This line corresponds to this line, so this measurement is proportional to this measurement. This line corresponds to this line, so this measurement is proportional to this measurement. However, we have a situation. We have inches and feet. So let's just set it up like we set it up before. We're going to set up our proportion smaller triangle to larger triangle, which means the fraction will look like small on top, large on the bottom. So this smaller triangle measurement on this side is 5 inches, so that'll be in the numerator, and it's proportional to this side, which is S. This is an S, and that is feet. Alright, and this is smaller to larger. We set that equal to these similar sides. The smaller is 4 inches and the larger is 6 feet. Okay, so we can't have inches in feet and inches in feet, because when we multiply 5 inches times 6 feet, that doesn't make sense. You have to have the same units to multiply 5 and 6. And what you need to decide is, do I change my inches to feet, or do I change my feet to inches? The best thing to do is change to the lowest unit. So the lowest unit in this situation is inches. So we're going to keep our inches and change our feet to inches. So let's fix our proportion. The 5 inches stays, and we don't have an S value on this one, so we'll just put S. And for this one, 4 inches stays inches. We have one value that is feet, and we're going to change that feet to inches. So 6 feet and we're going to use our little dimensional analysis that we've already talked about. We're going to multiply this 6 feet by a conversion factor. The conversion, of course, is 1 foot equals 12 inches. Okay, and that's just a crazy little equal sign there. But that is supposed to be an equal sign. 1 foot equals 12 inches. So as we know, on the diagonal, we will multiply by the conversion factor, where we have feet in the denominator, because we need to have feet on this diagonal, so it cancels, and then 12 inches goes in the numerator. So that when we're done multiplying 6 feet times 12 inches, so if I were to put it all on top of one fraction, 6 feet times 12 inches on top of a numerator, because I can do that since this is multiplied and 6 feet is really over 1. So then you can put 1 times the 1 foot. 1, let's see if I can do this right. Okay, that's the right way. So we cancel feet, because anything over anything, if it's feet over feet, that's still equal to 1. So our feet cancels. 1 times 1 is simply 1. 6 times 12 is 72, and then 1 times 1 is just 1. So we have 72 inches in 6 feet. So we're going to put 72 down here. Now when we multiply our proportion, it will make sense. Everything is in inches, and that will automatically give us an S value in inches. So let's do our multiplication. And remember, I showed how to do this before. We multiply the numbers on the diagonal and then divide by the number that's left over from the 3 numbers. This numerator times this denominator equals this numerator times this denominator. 5 times 72 times 72 divided by 4. And this is a 5. So 5 times 72 equals 360 on top, and that'll be divided by 4. Divided by 4 is 90. So this value, S, is 90 inches. S equals 90 inches. Now, since this picture shows this large triangle with 6 feet, and this S, if this S has a value of 90 inches, it doesn't make sense for a diagram to have 2 different units. So what makes sense is to change the 90 inches back to feet. So we're going to convert 90 inches to feet. So we start out with our 90 inches over 1, and we're going to multiply by a conversion factor. And our conversion factor, remember, is 1 feet equals 12 inches. So on the diagonal, we will put 12 inches. And that, of course, equals 1 foot. And we will multiply across, because this is multiplication. 90 times 1 is 90, divided by 12. Our inches cancel, so that we are ending up with feet. So we do 90 divided by 12, 7.5. So we get an answer of 7.5 feet. So that's better. If you're saying S equals, it's better to put it back to feet, because then that makes sense for the diagram. And if you're in the real world situation, you wouldn't measure one side of a triangle with inches and the other side with feet. Okay, so that's how you solve when you're given different units on your different triangles.